Hello everyone. As we have seen in our previous video about distance and displacement introduction in detail, right? Like we have seen units, its definition and what kind of a quantity it is. Both we have seen in our previous video. So in this video, let us see about few characteristics of distance as well as displacement. Clear? So to explain this characteristics, I would like to consider three different examples as three different cases I would like to write. So let us go through those cases straight away. So first, initially I would like to take it as case 1. Okay, case 1. Say a boy started from his house to a market, from his house to a market which is 100 meter away. Okay, this is the case which I considered over here. What did I say? A boy started from his house to a market which is 100 meter away. So what I would like to say, started from his house means the initial position of the boy is house and to a market which is 100 meter away. So after reaching market, what happened we don't know. So just assume that the final position of the boy is market. So what I'd like to say, the initial point of boy is house and the final point of the boy is market. So let us illustrate this one with a small diagram. So what I would like to say like this. So say this is his initial position, that is house, and we are having a market which is 100 meter away, So like this. Say house be A and market be B, and assuming that the boy traveled in a fixed direction. They like this. So in this example, what I would like to say is distance traveled by the boy. Okay, distance traveled by the boy is equals to what I could say directly as we learned it, length of path AB. Fine. So length of path AB is how much? From the figure we can say it is around 100 meter. Done. And now what we learned, the next one is displacement. And if you see here, displacement S is equals to shortest distance between initial and final, or also we said that it is the distance traveled between, or the distance between initial and final point, and that too it is in a specified direction or a given direction or a particular direction, however you need, you can say. So therefore here from the figure again we can say that the displacement is also 100 meter because the direction is unique and that is only one single direction. So from this, what I could conclude about distance and displacement is, if a particle is moving along straight line, then directly I would like to say distance will be equal to displacement. Then distance is equals to displacement. So this is the conclusion number 1 obtained by our case 1. Clear? I hope everyone got it. So now let us go to the case 2, which we are saying it to be of second characteristic we will be finding from this. Now again the same example about the boy only. A boy started from his house to a market which is 100 meter away, and then later he returned back to house. That's it. So again in this case, if you would like to understand clearly, see here, a boy started from his house to a market. So as usual, house is initial point of the person or the boy, to a market which is 100 meter away. Okay, he reached the market and then later he returned back to house. Again he came back to his house. So therefore his final position is again house only. So in this case, how to illustrate this what so and so example clearly? So let us take the diagrammatic form again. So as usual, we thought that this is his house, and then as we assume that the boy traveled in a given particular direction towards market, okay, and then which is 100 meter away. So therefore what we just said now, initially he traveled from house to market, and then he traveled back from market to house, again covered or moved along the same path. So therefore this is the depiction of the case where we have considered above. So now let us discuss the whole thing now. See here, distance again. In this case, distance d is equals to length of path traveled between 2 points. As usual we know. So between 2 points means that 2 points is nothing but initial and final only. So house is only initial, as he started from his house and then he reached back. So house is only your final position. So therefore you can say length of the path traveled, that is AB plus BC. So therefore AB is 100 meter and he returned back in the same thing. So therefore overall distance traveled by the person is 200 meter. This is fine. And now let us go into displacement, the next one. So denoted by S, magnitude form. What we said, this one, displacement is nothing but distance between initial and final point. Distance between initial and final point. So in the example, if you just understand here, the initial position is house only, final position is also house only. So the distance between initial and final position will be 0 because initial and final points are same. So directly you can say displacement is 0 meter. In bracket you can say initial and final points are same. Initial and final points are same. That's it. So I hope you have understood the conclusion of this case, right? What is the conclusion here? If initial and final points are same, then displacement will be 0, then displacement will be 0. From this what I can conclude that distance cannot be equal to 0, but displacement can be equals to 0. So this is our second conclusion from the second category, whatever we assume. So now let us go to the third one and the last one. So case 3. The same example, whatever the boy one, let us assume this one here. A boy started from his house. A boy started from his house to market, which is 100 meter away, and then later met his friend and went to his house. So whose house this is? Friend's house, which is 140 meter away as shown below. That's it. So let us have a depiction of this case, assumed to be like this now. So here what happened? The person or the boy started from the house, saying this is his initial position, and then he went to market, which is 100 meter away, later met his friend and went to his house. Whose house? Friend's house. So now the friend's house is your final point, and this is around away 140 meter away. So now let us have the diagram of this as shown below. You said, so say this is A and this is assumed to be of house, initial point. So therefore initial position, and say this is market. He just reached over there B, which is 100 meter away, and met his friend over there, and then he returned back from the market to his friend's house, which is 140 meter away. So this is C. So now in this case, if you see, the direction of the person is initially from house to market, and then from market to friend's house. So assume this point to be a reference house. Say this is a reference now. So as we know about coordinate system, take the help of the coordinate system straight away over here to understand this concept more clear. So say this is positive x-axis, this is negative x-axis, and this is along y-axis. This is so positive y-axis, negative y-axis, plus x, minus x, plus y, and minus y. Done. So now, as usual, our case is to find distance. Distance D is equals to length of the path traveled, as we know. So AB plus BC. So that is equals to 100 plus 140, which results in 240 meter. That is the distance traveled by the person. And now see the displacement. So in the diagram we can understand that house is the initial position, friend's house is final position. So you can say displacement will be from A to see that too along negative x-axis. So therefore, as displacement considers the direction, what I can say, until the reference position 100 and 100 gets tallied, out of 150, 100 gone. So the remaining position or this distance will be how much? 40 meter. So therefore, 40 meter along negative x-axis, or you can simply write down displacement S is equals to minus 40 meter. So most important category in understanding distance and displacement. So therefore, from this what I can say clearly, that distance cannot be negative. Distance cannot be negative, and displacement can be negative, and displacement can be negative. So this is the final conclusion where we get from this case considered over here. So therefore, on a whole, if you just look at all the three cases, we can straight away conclude that distance will be greater than displacement, and distance can be equal to displacement. Thus we can say that distance is always greater than or equal to displacement. First conclusion. Second conclusion, distance can never be equal to 0, but displacement can be equal to 0. And third one, distance cannot be negative, but displacement can be negative. So these are the three kind of characteristics where we can assume for distance and displacement individually or collectively whenever we discuss about any kind of a situation considered in our daily life. As we have taken three different examples over there in a above situation where we have seen a boy traveled his market and then friends house, in a different cases we have seen. So hope you all understood. If any doubts, please post in the comment section. Thank you. Have a great day.